Hello students, in this video we will be discussing rates of change, section 1.3 in the textbook, and the objectives are to just calculate the average rate of change given between 2 points on a graph or of a function, and then we're going to just interpret the rates of change. Okay, so let's start with number 1. Let's let E of t be the function that gives the enrollment at a university in year t. For example, the enrollment in the year 2008, E of 2008, is 20,167. Okay, so we're going to answer a few questions. So let's take a look at this graph, this table, and you can see that in 2008 the enrollment is 20,167, then it goes up to 27,040 in 2009. It dips down a little bit in 2010, and then it goes back up, and it goes up, and it goes up in 2013, up again, up again, up again a little bit from 2015 to 2016, then it jumps up in 2017. So if we were to describe how the enrollment has changed over time, well, from 2008 to 2017, the enrollment has increased, right? So generally, I would say generally the enrollment has increased over time. So the enrollment is increased as time proceeds. And I would say maybe generally because of that one dip down here. But if we're looking for the average rate of change over these years, right, what we're going to do is calculate a rate of change, right, which is a slope, right? So we want to take the enrollment in 2017, right, which would be 31,904, and you're going to subtract from that the enrollment in 2008, which was 20,167, right? And you're going to divide that by the number of years that have elapsed between those two. So it would be 2017 minus 2008. And this would be the average rate of change over those years. If you're going to do this calculation at home, I do recommend using Desmos as a calculator. So I'll just go into Desmos here, and you can, we can do this calculation pretty quickly. 30,904 minus 20,167 divided by 2017 minus 2008. And you can see we get 1,304.11111, right? That's in 1/9. So we get 1,304. I'll say it's approximately 1,304.1. Okay. So what does that mean? Right? That means that on average per year here, the enrollment has increased by 1,304.1 students. Okay. If we were to use function notation to express this average rate of change, right, we would write something like this. If the function is e, right, in this case, so it would be, we'd say e of 2017 minus e, the enrollment at 2008, divided by 2017 minus 2008, like that. Okay, that's if we were to write it in function notation. By the way, I would say this is the student enrollment per year. On average. Okay. Generally, if we use this function notation to write the average rate of change of enrollment between any two arbitrary years, T1 and T2, then the average rate of change is going to look like E of T2, right, minus E of T1 divided by T2 minus T1, okay? And the units I sort of mentioned up here already. It would be the number of students enrolled per year, right? It would be the number of students enrolled per year. Or students per year enrolled, right? How do these units relate to the input units, which was the time, the year, and the output units, which was the enrollment? Well, it's the quotient. It's the quotient of those units. What do I mean by that? It's output units divided by input units, right? So that would be number of students enrolled over the year, right? Or the time. Okay? Enrollment over time. All right. All right, let's move on. So how do we summarize the average rate of change? Well, we would say that the average rate of change for a function, a general function, let's say f of x, over some time, over some interval, let's say AB, is given by this equation, right? The ARC is going to be f of b minus f of a all over b minus a. You might notice this is a slope formula, right? So this is a slope of a line, right? And we'll discuss that a little bit later. Okay. Let's take a look at number 2. In this question, we're given the average cost function in dollars of a gallon of gasoline T years after 2000, right? So this is 2 years after the year 2000. That's 2002. The price of gas was $1.47 on average. In 2004, the average cost was $1.94, and so on. So we want to find the average rate of change between 2007 and 2009. Well, since this row of T years after 2000, right, this would represent 2002, this would represent 2003, 2004, 2005, and so on. So from 2007 to 2009, that's all over here, right? This is 2009. So really we're looking at this column and this column. Okay? So the average rate of change would be, right, the C of 2009 minus C of 2007 divided by the years, right? So it would be, well, actually, in this case, we're writing it like this, pardon me. It should be C of 9 minus C of 7, right? Since we're not using the full year, we're just using a code to get the year, right? And this would be then 9 minus 7, right? So that's easy to do as well. C of 9 we can see is 2.14, right? C of 7 is 2.64. and then you have 9 minus 7. Again, if you, well, this one we can kind of see what it is right away. $2.14, right, minus $2.64 is negative 0.5 cents, right? And that's divided by 2. And so we would get negative 0.25 or negative a quarter, right? Notice the average rate of change is negative, which indicates there's a decrease, right? It's going down instead of up. So this would be in dollars per year, right? Or 25 cents per year. Okay? So you should try some the WOMAT problems that correspond to this. You can pause the video and try them. Let's go on and do some more. Okay, in this problem we are given a graph. It's the Math Books Incorporated Publishing Company is conducting marketing analysis for releasing their titles as e-textbooks. The graph R of X gives the projected revenue R as a function of the selling price X. So we have revenue on the vertical axis, price, selling price on the horizontal axis. So we're asked to find the average rate of change of the projected revenue, R of X, on the price interval 5-10. So you can see 5-10 is from here to here, right? So we're looking at the graph, we're looking at this point here, right? And this point here. You can see R of 5, right, is 25, right? And you can see R of 10 is 40. So the average rate of change on this price interval is going to be R of 10 minus R of 5 all over 40 minus 25, right? Pardon me, excuse me, not 40 minus 25. This is 10 minus 5. And the numerator would give us the 40 minus 25 all over 10 minus 5, right? And you can see that's going to be 15 over 5, which is 3. So the average rate of change is 3. But what are the units on this thing? Well, we know it's revenue in millions of dollars, right? It's revenue over the price in dollars, right? So it would be $3 million. It's 3 over 1, right? So it's $3 million in revenue for every dollar that the price increases, right? So we're going to interpret this average rate of change. This is $3 million in revenue for every $1 for every $1 that the selling price increases. Right? And what we really did was we found the equation of a line, the slope of a line, excuse me, connecting these 2 points. Right? We found, let's see if I can get a line here. Hold on a second. We found the equation of this line, the slope of this line, excuse me. The average rate of change is the slope of that line. Or this line segment, I should say, since it has the endpoints. Okay, so the geometric interpretation of the average rate of change is it's the slope of a line, right? So the average rate of change, right, is the slope of what's called the secant line. right? Because you can think of, if you remember the slope formula, right, was like y2 minus y1 all over x2 minus x1, right? That's the change in y over change in x. But what is the change in y? The change in y is that we're just calling it something else now, right? We're calling it, f of b, f of a and b, right? So in this case, well, in the way this graph is written, a comes first, right? So it'd be f of a, f of b minus f of a all over b minus a, right? Which is a slope, right? The slope of this secant line. Okay. Let's move on. Well, what if we're just given a function equation, not a graph or not a table? Well, we could do the same thing, right? We can input the endpoints of the interval into the function and calculate the rate of change, right? So in this case, the average rate of change, right, is going to be f of 9 minus f of 1 all over 9 minus 1. And how do we compute that? Well, what's f of 9? F of 9, you simply plug in 9 or substitute 9 in for x into the function equation. So it's going to be 9 minus 2 times the square root of 9, which is equal to 9 minus 2 times 3, which is equal to 9 minus 6, which is equal to 3. And f of 1 is just going to be 1 minus 2 times the square root of 1, which is 1. So it's just 1 minus 2, which is negative 1, right? So the average rate of change here, you can see, is going to be f of 9, which is 3, minus negative 1, all over 9 minus 1, which gives us 4. 3 minus negative 1 is really 3 plus 1, so that's 4 over 8, which is 1/2. Right? So the average rate of change is 1/2. That means, what does that mean in this context? There really is no context here, it's just a function, right? It means that for every, on average, when y increases 1 unit, x is going to increase 2 units on average for over this particular interval 1, 9. Okay? All right, let's look at a slightly more algebraic problem here. So now, instead of numbers, we have x. We're starting at x, and then we're adding some value h to x. So we're going from x to a little bit more than x, right? So just to give you the idea, if this is x, right, then x plus h is a little bit more down the line. We're going to assume h is a positive small number, right? So we're going down here to x plus, and we want to find the average value of this particular function over this interval, right? So this is a little more abstracted because there's no numbers here, but we can still perform the computation, using algebra. So what we're going to do is the average rate of change, right, is going to be g of x plus h minus g of x, right, all over x plus h minus x, right? And so what we want to do is get each element here. The denominator is kind of easy. It's x plus h minus x. When you subtract x from x plus h, you're just left with h in the bottom, right? And we know what g of x is, right? G of x is easy. That's just given to us. It's 3x squared minus 2. But g of x plus h is something different that we have to compute. X plus h is now a sort of function within a function. You can think of it as a composition of functions, right? So we're going to plug in x plus h in for x here. So it's going to be 3 times x plus h squared minus 2, like that. And when you do that, you'll see you're going to multiply this out, right? Maybe I'll do a little scratch work here for you, right? X plus h times itself, x plus h, right? You're going to do FOIL or distribution, right? It's going to be x squared plus xh plus another xh plus h squared, right? So you get x squared plus 2xh plus h squared. So this is going to be 3 times the quantity x squared plus 2xh plus h squared minus 2. And now this looks a little weird. Let me make sure these are close together. It's going to be 2xh, right? And now you can distribute the 3, right, to all the members of this term. So it's 3, 3, 3. It's going to be 3x squared plus 6xh plus 3h squared minus 2. Okay? And now what we're going to do is plug that into this numerator here. So we have g of x plus h is this red quantity. I'm going to write it in. It's 3x squared plus 6xh plus 3h squared minus 2, right? But then we have to subtract from that the quantity 3x squared minus 2. Now be careful here because you want this in parentheses because you're going to have to distribute this negative sign like that. And so what we'll get is the average rate of change. Here, let me grab this and put it on a new page so we have some room to work. There's not much more to this, but let's put it down here and we'll simplify it a little. There we go. Okay, so what are we going to do here? We're going to rewrite this. It's going to be 3x squared plus 6xh plus 3h squared minus 2, and then it's going to be a minus 3x squared, and then a minus 2, which is a plus 2, all over h, right? And you'll see some things cancel out nicely. So the minus 2 and the plus 2 go away, and the 3x squared and the minus 3x squared go away. And what are we left with? We're left with 6xh plus 3h squared over h, right? So that's our average rate of change. And now we can simplify even further because notice the numerator, both of these terms have a factor of h. So I can pull out that h, and I could write this as 6x plus 3h, right, all over h. And then these h's will divide out, and you'll wind up with just 6x plus 3h. So that is the average rate of change that we're looking for over that interval x to x plus h. Okay, so just to recap, what did we do here? We defined the average rate of change. We computed the average rate of change from a table, from a graph, and also given a function equation. And then we also interpreted the average rate of change when we were given a context, like in this case where it was $3 million in revenue for every dollar that the selling price increases, right? So please review this video. Let me know if you have any questions, and I'll see you next time. Thank you.